Hello everyone. In this video, we are going to see the solved numericals which are based on the solid mechanics, covering with the concept required to solve these numericals. Starting with the first numerical, what will be the relation between E and K when mu is equal to 0.25? Before starting the solution, we are going to see the different relation between E, K, G and mu, in which first relation is E is equal to 3K into 1 minus 2 mu. Second relation is E is equal to 2 times G into 1 plus mu. Third relation is E is equal to 9 kg upon 3K plus G, and mu is equal to 3K minus 2G upon 6K plus 2G, where E is equal to Young's modulus of elasticity, K is bulk modulus, G is modulus of rigidity, and mu is Poisson's ratio. Moving towards the solution, here E is equal to 3K into 1 minus 2 mu, but mu is given as 0.25. Therefore, E is equal to 3K into 1 minus 2 times 0.25, which is equal to 3K into 1 minus 0.5, which gives E is equal to 1.5K. The answer is option C. Moving towards the second question, an axial tensile force is acting on a body and normal strain in the axial direction is 1.25 mm per meter. If the Poisson's ratio is 0.3, then what will be the volumetric strain in the body? The volumetric strain in the body will be given as epsilon V is equal to epsilon into 1 minus 2 by m. Here 1 upon m means mu. So epsilon is given as longitudinal strain, which is equal to the normal strain in the axial direction, equals to 1.25 mm per meter, which is converted into meter and multiplied by 1 minus 2 times mu. So volumetric strain will be obtained as 5 into 10 to the power minus 4. Then third question, a point in a strained body is subjected to the tensile stress of 100 MPa on one plane and tensile stress of 50 MPa on plane right angle to it. If these planes are carrying the shear stresses of 50 MPa, then principal stresses are inclined to layer normal stress at an angle of. In this example, the tensile stress of 100 MPa is acting on one plane and the tensile stress of 50 MPa is acting on right angle to that plane. So, tensile stresses are considered as positive while compressive stresses are considered as negative, and the shear stress is given as 50 MPa. We have to find the angle of the principal stress, which is given by tan of 2 theta is equals to 2 times shear stress upon stress in the x direction minus stress in the y direction. So, substituting the values of tau and the sigma, we get tan of 2 theta is equal to 2 times 50 upon 100 minus 50, which gives angle theta as half of tan inverse of 2. Then next example is slope at the end of simply supported beam of span 2 meter and load 5 kg per unit length over the entire span will be. Solution. In case of the simply supported beam, the slope at the end support is given by using the formula as theta is equal to WL cube upon 24 EI. Here the value of W is given as a 5 kg and span is given as 2 meter. So putting this value, we get the slope at end support as 5 upon 3 EI. Next question. If simply supported circular beam with dia D, length L carries the concentrated load of W at the center of beam, then the strength of the beam is proportional to the. Before moving to the solution, we are going to see the flexure formula. The flexure equation is M upon I is equal to sigma upon Y is equal to E upon R, where M is moment of resistance having unit as Newton mm, then I is moment of inertia having unit as mm to the power 4, sigma is bending stress having unit as Newton per mm square, which is also called as MPa. Then Y is the distance of the layer which is subjected to bending from neutral axis having unit as mm, then E is equal to Young's modulus having unit as Newton per mm square, and R is the radius of curvature of the beam. From the flexure formula, we can see that the moment of resistance is equal to sigma into I upon Y, where I upon Y is section modulus, which is denoted as Z. From this, we can see that moment of resistance is directly proportional to the section modulus, as the moment of resistance increases, the strength of the member also increases, and chances of failure of member decreases. Then, moving towards the solution, as the strength of beam is directly proportional to the section modulus, where the section modulus is I upon Y. For circular beam, I is pi upon 64 times d to the power 4 and the value of Y is d upon 2. So, Z is directly proportional to the pi upon 64 into d to the power 4 upon d by 2, which gives Z means strength of the beam is directly proportional to the diameter cube.